Welcome to Mode Concept. We are still on Introduction to Embedded Systems. Now the lab 3. So our lab 3 is blinking LEDs with an MCU, that is microcontroller unit. We have blinked one LED. Now we are blinking LEDs. That means more than one LED. This will equally give us an insight into traffic lighting system, traffic light control. So our aim here is to understand and get familiar with the technique behind blinking LEDs using microcontroller unit, which will, as I said earlier, give us an insight into traffic light control. So our requirement still remains the same: Proteus simulation software installed on a PC, MikroBASIC compiler, power supply source, and a lot of components as our circuit has shown. So, a brief theory. This blinking of LED is just the foundation of the design of traffic light control and vehicle trafficator and the similar lighting systems. So now this is our diagram, our circuit diagram. We are going to realize this circuit diagram using Proteus. After we now write our program and go back to Proteus to simulate and see how it works. You see from here that our LED is attached to port B.0, port B.2, and port B.4. You see, so I will not just go through this procedure because I am going to do it so that you will see how it is done. So I'm not going to start reading out these procedures. So I'll quickly open my Proteus simulation software from the taskbar. So it has opened. I'll just go straight to schematic capture. Now this is schematic capture to start my project. I am going to go to P to pick my components. PIC16F628A. That is it. I'll pick it up. It will appear under devices. I'll go back and pick my resistor. Min res 330 ohm. Ohm is R. I'll pick it. I'll go back again and pick my LED dash red, so as to go straight and bring out LED red. That is it. I'll pick it. That's all I need. I'm going to say okay. Let me start my design. Okay. I'm going to zoom to see very better. Okay. Now, resistor port B.0 again, port B.2, port B.4. So I'm going to hide some of the features of this resistor so that it will not be clustered as it is here. I'll just double click on it. See, hide. I'll hide this and this. Okay. Hide. No. Cancel. Hide. Hide this. Hide this. Okay. So I'm going to leave this like that. R3 and 330 ohm to show us the value of the rest. So I will pick up my LED. I'm going to turn it. I'll keep it this way. Let me equally hide the properties. Okay, so now I'm going to make my connection. That is it. Switch on. So pick my ground from terminal mode. Ground. But I have a common ground. Common ground. Okay. Now I am done with my design. I'm not going to connect any power supply because it's already connected. The oscillators are internal. That's all. So I'm going to go and write my program. I'll just go to MikroBASIC. Okay. Has opened. Okay, has opened. I'm going to close this pop-up or move it. I'll just go to new project. Standard project, I'll say next. My project name, let's see. CTE. Lab. CT205. CT205. LAB3. So where do I want to save the work? I'll go to browse and choose that same folder I was using inside document. CT205. So I'm gonna say okay. So my oscillator, I need 10 mega. Okay, let's go to next. Finish. Okay, so now because I have already written my program before using on PowerPoint when I was preparing for the class, I won't just start typing it over again. I will just go straight to where my program is and copy it. So this is my program here. I'm going to copy it. I'll say Control A, Control C. I've copied it. I'll go back to MikroBASIC and paste it. I will leave my title, paste it, Control V. So I'm going to check if there's something I need to correct. Blinking 3 LEDs. This should be a comment. Good. Close this gap. Okay. This is just making the work look good for the sake of aesthetics. So now this program, I said trees B equal to 0. That is, all the B ports should be an output port. That's why the trees B equal to 0, meaning that all the B ports should be an output port. Port B equal to 0. All the port B ports are enabled as digital ports. Then CM equal to 7, comparator control. Then I'll now start my program proper. I'll save. Start my program proper. Port B.0, first LED equal to 1. Wait for 0.5 seconds. Turn it off. Port B.3. No, use port B.2, not 3. Port B.2 equal to 1, that's the second LED, comes up. As the first one is going off, the second one is coming up at the same time. So then let it remain on for this 0.5 seconds. Then turn off the second LED attached to port B.2 and turn on port B.4, that is the third LED at the same time, and leave it on for 0.5 seconds. Then turn it off. When you turn it off, you go back to start. This start. You turn it off and go back to start and turn on port B.0. You will see how this will work. Let's run the program and see what we have. Let's save. Run. Check it has run, it has compiled. I will now go to my design on Proteus. Double click on this microcontroller. Now go to program file. I have it in my documents. CT20522. Set it as CT205 LAB3. That's it here. That's the hex file. Now change my oscillator to 10 as just before. I'll say okay. So I will now run my simulation, see the behavior. I'll go to you see. Okay. See. So we can start to change the colors of this LED. Let me pause and change the colors so that it will be final. I'll just go back to component mode. P. See, LED dash yellow. See already. LED dash green. See already. I wanna say okay. So I will turn my LED IP the green. Just turn it so as to be in line with this one. I'll drop it here. Replace. I'll pick the yellow. So return it to and now drop it here. Say replace. Now go back to simulation. Simulate. So see, our work now has a different shape. You can decide to delay the red more and make this one yellow momentarily. Let's just go back to our program and do that. MikroBASIC. We'll just come here. Red is at port B.0. We'll now increase this time to, let's say 2002 seconds. And now leave this one at 8.8 seconds. Then leave this one at the green at 2500. So that's 2.5 seconds. Now save, build. Now go back to my design and see the behavior. Proteus. I will now run straight. It has already updated itself here because I stopped simulation before editing the program. But had it been this was still running before I went to edit the program, I will still need to go in again and upload it. So I will just go straight to simulate. Okay. So this looks like traffic light. Red means stop. Get ready and go. Stop. Get ready and go. Stop. Get ready and go. So that is that. You can still decide to do it in a way that when this man will still remain on when this man comes up before it will go off. But that is just a different program. We can still do that, but I will just encourage you to do that. Let this one come up. While it's up, this one will later join it in being on, and after they will both go off. This one will not come, green will not come up, and before red comes up again, yellow comes when this green is still on. Then after some time, the yellow and the green goes off and red comes up. You can now do this on your own and show me what you have on the comment section. So let us continue with the rest of the lab. So having done this simulation, we have seen that it's working as desired. We'll now continue to the next stage, which is the program. I have explained that. So this is the simulation which we have just done. This is the one I did before. So it's the same thing. So the next thing you need to do is to write down your observations. What did you observe? For me, I observed that the LED we are blinking at different intervals based on the delay time. I equally observed again that the when you can use different colors of LED to beautify your work. See, then which precaution did I take? I did my design first before I write my program to make sure that my program tallies with my design. That's one of my precautions, and I picked the right components, you see, and turned them to as in orientate them the way it will make my work look neat and now make my connections properly. So in my conclusion, the blinking of LED is just the foundation of traffic light control and other similar lighting systems. So with this, we come to the end of this lab. Thank you for being with me from the beginning of this lab 3 to the end. And I believe you have really gathered a lot of knowledge. Like the video and subscribe to our channel. Do your own homework or assignments or whatever, and drop your comment in the comment section. Thank you very much. Bye.